So we will start with a set of revision questions today. So this is the first one. I still have a few students joining in. Anyway. So start with this question, start working this out, and you can send me your answers over the text message. So for those of you who just joined in, we are doing a revision exercise set in the class today, and this is like a class exercise for you people to work out questions, and through that, revise the portion of vectors which is relevant for the test coming up on Sunday. Yes, Shashwat, your answer is correct. Arnav, your answer is correct. Varun, correct. Amok, correct. Hamil, correct. Aditya, correct. Pritesh, correct. Rakshit, correct. Yashwardhan, you have to work out your answer again. Aman, also correct. Anushka, correct. Both the parts. Manas, correct. Yes, Aman, your answer is correct. Yes, Shashwat, your second part is also correct. Shubham, correct. Dhamil, you have to check your answer for the second part. The first part was correct. Check your answer for the second part. Aditya, correct. Siddhi, correct. Varun, you have to check the angle again. Yes, Varun, correct of the magnitude. Yeah, Dharmil is correct now. The angle is correct. Pritesh, correct for the angle. Okay, so continue working on this. I'll also put up another third question in the meantime. Okay, plenty of people have got the first answer correct. Yes, Varun, the angle is correct now. So I'll just put up the answers for part A and B. So here the answer for this part A should be 50 and part B should be 37 degrees. Yes, Chinmay, that is correct. Yes, Aditya, your second question is correct. Anushka, your second question is correct. Naman, you will have to check your second question. The first part is correct. The second part, you have to check the angle carefully. So this question, A part's answer should be 20 root 3 and B part's answer should be 90 degrees. Yes, we will do all the questions, don't worry. Satyam, I'll explain the multiple methods possible for all the questions. First, I just want all of you to give this a try. Yes, very good, Aditya. Third part is correct. Third question is correct for you. Okay, so for the third question, I will start by giving you people a hint. Okay. The hint for the third question is draw vectors A and B on an XY plane. and then figure out the angle between them. No, Uday, you are on the correct track, but unfortunately your answer, you made some silly mistake. Just probably it is just some careless mistake or something. Just check it out. Okay. Yes, Pranaya, your answer is correct for the third question. Manas, again, there is some mistake you made, madam. Probably some calculation mistake. You're on the right track. Okay, so while people are working on the third question, those of you who are doing that, let me explain the first question in detail. So first question, we have two methods of working it out actually. Whichever method you find suitable at this stage is fine. So question 1, your mod A is given to you as 10. Mod B is given to you as 30 root 2, and the angle theta between them is given as 45 degrees. So the first method is you just apply the triangle law. Triangle law / parallelogram law. Both have the same statement. That magnitude of A plus B is root of A square plus B square plus 2AB cos theta. And the angle alpha is equal to B sin theta upon E plus B cos theta. We just substitute all this information here. So 100 plus 1800 plus 2 into 10 into 30 root 2 into 1 by root 2. So as you can see, this becomes square root of 100 plus 1800 plus 600. So that's root 2500 or 50. Okay. And you also substitute that here. So we get tan alpha equals to 30 root 2 into 1 by root 2 divided by 10 plus 30 root 2 into 1 by root. So further this becomes 30 upon 10 plus 30 or 3 by 4. So tan alpha equal to 3 by 4 implies that alpha is 37 degrees. That becomes our final answer. So this is the first method of solving this. Formula method, formula based method. You can also see the corresponding, geometrical solution, how this would look like. If you were to solve this geometrically, this is how your vector A looks, and if you were drawing a triangle, the vector B you draw from here, something like this. So this is of magnitude 10, this is of magnitude 30 root 2. And this angle here is 45 degrees. So the resultant here would be this one. So this is how our vector triangle would look like. And this would be our angle alpha. Now we could solve this by dropping the perpendicular here and just applying Pythagoras theorem and all that. Or consequently, if you want to make the vector parallelogram, that would look something like this. You draw vectors E and B from a common origin. Let's say this would be your theta, the angle between them. Then you draw two lines which are parallel to these two. Here. Let's say, okay. And you see the primary diagonal would become your vector sum. This angle here would be your alpha. But the point is the formula would be the same. If we do the vector parallelogram or the vector triangle, still in both of these the formula would be the same. Use the same set of formula. Okay. So this is just briefly the geometrical approach for doing both these questions. I mean, doing this question. Yes, the answer is correct for the third one. So I'm also putting up the answer for the third part now. But before that, those of you who are still working out this question, just make a note of this. Okay. So this would be the good, correct, Jawad. Utsav, your answer is correct. Yes, Naman, your answer is correct. Good for the third question. So I'm putting up the answer for the third question now, since most of you have already got it. Okay. So you should be getting the answer of this as 105 degrees. For this one. So if you finish the first and second question, just go through the third question, try it out. Okay. If you're still on the first and second question, just pay attention and working out the solutions. Alright, so hope you've taken down the data for the second and third question. Okay. Now coming back to the first question. Yeah, Chinmay, no problem. First question, there's an alternate method also we can use, which is the component approach. So we can also use for the first question. You always apply the component algebra method. So in that, assume our x-axis is along the vector E. In that case, our E automatically becomes 10 I cap, because that is how we placed our x-axis. Since nothing is given in the question about where the x-axis is, so we are free to select our x-axis wherever we like. So we just happen to have taken the x-axis to be the axis which is along the vector E. So we just assumed our x-axis is like this, our y-axis is like this. So now in this xy system, our vector B, the only information we have about it is that vector B has a magnitude of 30√2, and it is at theta equal to 45 degrees with respect to vector E. This is the information that we have about vector B. So just accordingly draw a vector. It doesn't matter where we draw it. We can draw it from the origin of A. We can draw it from this origin. We can draw it anywhere we like. But as long as that information is correct, that it is making an angle of 45 degrees with respect to vector E, and therefore in this case it's making an angle of 45 degrees with the x-axis. So this angle here is 45 degrees. Its magnitude is 30√2. So the moment we have done this, okay, here, so that now implies that the vector B has an x component of 30 root 2 into cos theta, where theta is 45. This is the x component. And 30 root 2 sine 45. Or we can express the vector B accordingly as 30 I cap plus 30 j cap. So now I have vectors A and B component form. So now I come to the resultant. So I don't need to go back to the diagram and all that. I'll just use component algebra. So A plus B, you can call the resultant, is simply 10 I cap, which is vector A, plus 30 I cap plus 30 j cap. So you are all familiar with all this now, so it's no problem. So you can see it as 10 plus 30 is the resultant's x component, whereas 0 plus 30 is the resultant's y component. So it's that 40 I cap plus 30 j cap kind of vector. This is the resultant. So now we can see that both the things can be answered from here. That the magnitude of A plus B, which is the magnitude of the resultant, is the magnitude of this vector 40 I cap plus 30 j cap. Now just use your component algebra. So it is x square plus y square, the sum square root. So that becomes 50. So that becomes your first part's answer. And similarly, you can work out the angle that the resultant is making with respect to the y-axis. With respect to the x-axis. You can see the angle will be such that your tan theta or tan alpha in this case will be how much? Y component divided by x component. So 30 by 40. So it will be 3 by 4. So tan alpha is 3 by 4 means again alpha is 37 degrees. Okay. So this is how we work out. Yeah, Harsh, no problems. Okay. So just complete these two problems. Unfortunately, I have a software hang again. So just give me a minute, guys. I need to restart. So just wait a minute, guys. I need to restart the whiteboard software. So while I'm rebooting people, okay, I'll just try to give you the data of question 3 again, so that you can start with that in case you're done with 1 and 2. Just a minute. Yeah, so here is the data of question 3. It's like this: the vector E was root 3 I cap plus j cap, and the vector B is minus 2 I cap plus 2 j cap, and we wanted to find the angle theta between them. So in case you haven't worked this question out, the hint I had given for this is you have to just draw the two vectors A and B in the XY plane, and from that you should be able to get the answer. So the angle, when you work it out, it should in fact come out to be 105 degrees. So just try out that question. It should come out to be 105 degrees. So just give me another minute here and the whiteboard will be back online with both the questions and everything. Okay, so just yes, third one's answer is 105 degrees. That's correct. Right. So again, I'm just leaving you with the solution one moment for the second method for question 1. So we got R as a vector. So you can see that the magnitude of A plus B is the magnitude of the vector R. So that is 50. And angle of the resultant with respect to E. Now E is along x-axis. So basically this angle is the angle of the resultant with respect to the x-axis. So the resultant vector, whatever angle it is making with the x-axis, ultimately that is the angle it's making with the vector E. So now this is our resultant, which is 40 I cap plus 30 j cap. And in comparison, this was our vector E. Our vector E was along the x-axis and of magnitude or of value 10 I cap. So I want to find out this angle. So it is basically just drop this perpendicular here. This is the x and y axis only. So this angle here is such that tan alpha is resultants y component upon resultants x component. So that is 30 by 40. So the same thing. Alpha is 30 something. Okay, so this is the solution of the first question by the second method, by the component algebra method. So those of you who are still working this question out, make sure the second method is clear. Yes, and now to answer your question, you can use that dot product method, but I don't expect you to right now because we haven't learned dot product yet. Okay, so when we learn it, I'll teach you by that method also. Okay, now let's quickly come to the second question. Okay, now the second question is again that way. You can do it by two methods. Okay, so let me pick up the diagram of the second question. Use the diagram in the solution below. Okay. So for the second question, again you have two methods. One is you can use the formula method. Magnitude of A is 20, magnitude of B is 40. But see the angle between them, that angle is how much? That is in fact 120 degrees. So the angle between vectors A and B here is not 60. The angle between vectors A and B is this one. This is 120. So if you were, for example, applying the triangle law, you would have to draw the vectors A and B like this. You would have to draw them back to back. You have to draw them like this. Where this would be the angle between A and B. That you can see from the figure is 120 degrees. So this is where you should not get confused with the angle involved between the two vectors. Or for example, if you were drawing a parallelogram, then you would draw the vectors in this way. You draw vector A like this, and you draw vector B the same way it is drawn over there. But then you would complete the parallelogram like this now. So this would be the vector parallelogram. And in that parallelogram, this angle theta is 120 degrees. This vector B is 40 in magnitude, and this vector E is 20. But again, the thing is whether you're using this diagram or using this one to find the resultant, ultimately the formula for the resultant will be the same, and that is the common statement of parallelogram law or triangle law, that mod A plus B is root of A square plus B square, that one. Okay. So in this, you will substitute cos theta as cos 120, which remember in second quadrant cos becomes negative, so it's minus cos 60. So this should be substituted as minus half. So that is the thing. Here cos theta should be substituted as minus half. So when you do that, you will get the magnitude of A plus B, substitute everything, and you will get the magnitude as 20 root 3. And also you will have to substitute this tan alpha is equal to B sin theta upon A plus B cos theta. So in this, when you substitute, sin theta will become sin 120, which will become positive of sin 60 or root 3 by 2. But when you substitute cos theta as minus half in the denominator, you will get tan alpha as 40 into half, sorry, root 3 by 2, but divided by 0. So it is undefined. So the fact that it is undefined means that alpha is equal to how much? It is 90 degrees. So this is the formula based approach, which is based on the triangle law or the parallelogram. So whether you have gone with the triangle or the parallelogram, if you want to complete the diagram there, you would see that the resultant would be this one. The resultant would be in fact like this. In a perfect diagram, it would be like this, and of magnitude 20 root 3, and this angle would be 90 degrees. Okay, similarly here, if it were a perfect diagram, this actually would not be like this. This would be like this. So in fact, my parallelogram would look something like this. It should be a bit shorter, so that it's roughly speaking a little bit like this. This angle would be 90 degrees. So this is how my parallelogram would look. This is how my triangle would look. But again, unnecessary to draw them, because if you are going with this method, you can use the formula. Alternately, you can also go with the component method. If you go with the component method, you would still concentrate on this diagram here and just write vector E as 20 I cap. Vector B would become 40 cos 120 I cap plus 40 sin 120 J cap. Now using the values of cos and sin like we've already done, you would have got the vector B as minus 20 I cap plus 20 root 3 J cap. So you got vector B, you got vector E. Now just add them. So you would see that the resultant would be 20 and minus 20 would cancel, so 0 I cap plus 20 root 3 J cap. So this would be the resultant. So you can see that the magnitude of the resultant would just be 20 root 3, and it is at 90 degrees to x-axis, or that's the same as 90 degrees to E, because the vector E is already drawn along the x-axis. So this would also be a convenient method of solving this question. No, Dhruv, in Sunday's test, as I've already mentioned, the syllabus is only up to the last lecture, that is lecture 5. So you will not have dot and cross product at all in it, but you will have three-dimensional vectors interpretation. So I'm coming to a couple of questions based on that. Vector products, both scalar product and vector product, or dot product and cross product, will be coming in the next test that we have. This test will just be about resolving vectors, components, and sum and difference and these kind of operations. Good answer. Okay, so I hope this is clear to all of you. Okay. Now let's move on to the third question. So I'll quickly work it out for people who are still working on it. Okay, so the vector E was given to us as root 3 I cap plus J cap, and the vector B was given to us as minus 2 I cap plus 2 J cap. So to understand the angle theta between them, all we have to do is we have to visualize these vectors in the xy plane, how they look with respect to the xy axis, so that we can find their individual angles with respect to the xy axis. So in a system of two mutually perpendicular xy axis like this, if I were to draw the vector E, You can see from this, it would have a positive x component and a positive y component. So the vector E, if I draw it from the origin, it will be lying in the first quadrant. It will be lying in the first quadrant such that this value here would be the y component, would be unity, and this value here would be the x component, it would be root 3. So this is my vector E, and this angle suppose is alpha. Just for variety, I'm naming it as alpha. So you can see that tan alpha is 1 by root 3. So alpha is equal to 30 degrees. I mean, if you've been doing vectors enough by now, it will be very clear. You look at this vector and almost immediately you realize that tan theta is 1 by root 3 and both the components are positive. So it's making an angle of 30 degrees. Similarly, you look at this vector B and it becomes abundantly clear that this one has a negative x component and a positive y component. So the angle is making is in the second quadrant. And you can see that tan of theta for it is nothing but 1 upon minus 1 or 2 upon minus 2, that's minus 1. So it is nothing but 135 degrees. It's 180 minus 45. So it's not surprising at all. Okay. But anyway, so let's draw this formally over here. So this vector would look like this. It would exactly bisect this angle. Something like this. You can also see this is a longer vector, so I'm trying to be accurate, even though it doesn't matter. This vector has magnitude 2 root 2. This vector has magnitude only 2. So I've drawn this one slightly longer. Now you can see that if this vector, these components when you draw it, this component is plus 2 and this component is minus 2. So now if you talk about this angle here, you can see beta is in the second, so let's call this angle beta. You can see beta is in the second quadrant such that tan beta is minus 1. So in other words, minus of tan 180 minus beta. You don't need to do all this. Right? You can already see this angle is 45, so this is 135. I'm just showing you once again how to formally write these things. Okay. So so tan beta in second quadrant, the formula becomes like this, that tan theta is minus of tan 180 minus theta. If you write it formally like this, so this thing is equal to minus 1. So that means tan of 180 minus beta should be 1. And this 180 minus beta should be an acute angle. So we can just write 180 minus beta as 45 degrees, or as expected, our beta comes out to be 135 degrees. So we got beta and earlier we got alpha. And now we are looking for the angle between these two. So we got alpha here, we got beta here. Now we are looking for which angle in the diagram. We are looking for the angle between A and B. So that is this angle here. This angle we are looking for. This angle is how much? So you can see that theta is nothing but beta minus alpha. So it becomes 135 degrees minus 30 degrees. So in this particular case, the angle between the two vectors is 105 degrees. Okay, so this is the complete solution of the third question. Okay. And at the moment, this is the unique method we use for it. There is also another method by using something called dot products. But first of all, in this case, it will not give you 105 if you use that method. It will give you the answer in terms of cos inverse or something, and it will be very lengthy trigonometrically to prove that cos inverse angle is coming out to be 105. Firstly, that. And secondly, we haven't learned dot product formally yet, so let that be. Okay, just let's do this question from what we have learned so far, and this is the method of solving it from that. Okay, so hope this is clear. Okay, now let me quickly do some questions based on three-dimensional component system. But these will be very easy because it's just an extension of the two-dimensional concept. So these are more or less just direct application questions. But just to make sure that you have enough practice. So the vector E is, let us say, I cap minus j cap plus k cap. The vector b is I cap plus 2j cap plus k cap. And the vector c is, let us say, j cap minus k. Now I want you to find the vector e plus b plus c in IJK notation. And magnitude of a plus b plus c. Yes, Dhruv correct, Chinmay correct, very good. Nothing difficult. Okay, yes. Now tell me the magnitude also. Naman correct. Dharmil correct. Very good. Aman, Utsav, Dhruv, all your answers are correct for magnitude also. Vaishnavi answer is correct, good. Aditya correct. Asmi correct. Vineet. Commutative law, it's okay. I mean, don't really have to bother about that. It's just algebra. Just do a plus b plus c. So, replace these with each of these. So I see some students unfortunately are having trouble with internet connectivity and you're getting logged out and then logging in again. So just since we are doing revision questions, nothing to worry about. Just make sure you see the video of the lecture later today and also work out the questions yourself. You should be fine. So anyway, let us work this out. So it's pretty simple here. So A plus B plus C now I'm just doing this fully. You need not apply so many steps yourself. You can just do them directly also. So this is I cap minus J cap plus K cap. That is the vector A plus the vector B, which is I plus 2J plus K. So that is the point. We need not apply commutative principle here. We can directly add all these. So all we have to do is open the brackets now and take I cap common, J cap common. So with I cap we have 1 plus 1 plus 0. That is the sum of the x components. With J cap, the sum of the x, the y components are minus 1, because remember it's algebraic sum. So minus 1 plus 2 plus 1. And with K cap, the sum of the components are 1 plus 1 minus 1. Mistake. So that's it. Okay. So finally, you can see that this is working out to be 2I cap plus 2J cap plus K cap. This is my vector A plus B plus C. In I cap, J cap, K cap notation, or in component notation. So its magnitude, remember, is square root of x square plus y square plus z square. So that's it now. So mod of this becomes square root of the x component square plus the y component square plus the z component square, which is 3. So that's it. I mean, there's nothing more difficult in dealing with three-dimensional components. There's nothing more difficult than anything you've seen before. Just need to keep in mind that the magnitude of a vector becomes square root of x square plus y square plus z square. Thanks. Okay, now let us do a problem which is a little bit about visualization in 3D. Okay, so now this question that I'm doing is a most tricky type of question than what we've seen so far. Okay. let's say we have an example question like this, that an object undergoes a displacement on land, horizontal displacement on land, so S1, which is, let us say, 50 kilometers at 37 degrees north of east. Then a further displacement by C, okay, and the further displacement is also horizontal, of S2, and let us say that that displacement is 20 kilometers towards south. And finally, a vertical lift by elevator of S3, that is, let us say, this seems very extraordinary, but okay, so let's say it is 5 kilometers vertically up. So first of all, take Cartesian system such that I cap is pointing towards east, J cap towards north, and K cap vertically up. So you can say vertically up means opposite gravity. And these two, so the XY plane will be horizontal. So take the Cartesian system such that this is happening and express S1, S2 and S3 in component notation. And then find the net displacement, which is the resultant sum and its magnitude. Okay, so this is a question where you have to just visualize things a little carefully. Otherwise, it's pretty easy. Okay, so I will just give you some time to work this out. So start with the first part where you take the Cartesian system as I have explained over here and first express S1, S2 and S3 in component form. Yes, S3 is 5 kilometers vertically up. So it will be 5K cap. Correct, Harpriya, your answer is correct for the first part. S1. Yes, correct, Pranaya. Okay, Harsh, understood. So if you want to re-log in, you can try that also. The resultant magnitude is 25, is it? Okay, so let's check it out. Okay, so let me first try and draw a three-dimensional diagram to explain what is happening here. So if I attempt a three-dimensional diagram, it will be something like this. Let's say this is your horizontal XY plane, in which this is your y-axis pointing north, this is your x-axis pointing east, and this is basically a horizontal ground. So the XY plane is the horizontal XY plane. So south is here and west is. Now in this diagram, my vertical axis would look like this. It would be cutting this plane perpendicularly. This is what my vertical axis is. So this is what my Z axis would look like. This is vertical. So gravity would be pointing downwards like this. So this angle is 90, this angle is 90. So now it's going to be very difficult to plot the displacements over here, but you'll realize that if you try that, your displacement S1 would be somewhere towards, it was northeast like this, so it would look like a displacement like this. Then your displacement S2 would look towards south, so it would be something like this, let's say, pointing southwards. And your final displacement, which has happened by vertical lift upwards, okay, that would be vertically upward from that point. So this is how it would. So I have to try and imagine this in 3D, okay? Because there's no other way we can draw it accurately over here. So now what we can do is we can break this diagram into two parts. One is, so alternately what we can do here is something more convenient. Let us look straight into the horizontal plane. So that is along gravity. You are looking along gravity. You're looking in the vertically downward direction. So this is how your horizontal plane would look like. Yes, I think. Okay. So in this now it's very easy to understand how your S1 and S2 are looking. S1 was a displacement 37 degrees north of east. So it would be like this. And its magnitude was 50 kilometers. And this angle was 37. So when I write S1 in component form, you would see that I would just get it as 40 I cap plus 30 J cap in kilometers. Now, since we are doing a vector with components with unit, you should understand one thing over here, just a technicality. ये जो I cap और J cap है, उसका कोई unit नहीं होता है, because they are base unit vectors. So the kilometers is the unit of the component. So this 40 is not just a number here; it is actually 40 kilometers. And similarly, the 30 is 30 kilometers. So properly reading this out, this vector S1 is 40 kilometers I cap plus 30 kilometers J cap. So that's how we understand the units. Now in the same diagram, how is my second displacement S2 looking like? So you went by land from here to here 50 kilometers, and then by sea you went straight towards south. And I think you made a displacement of how much was it? 20 or something? Right. So 20 kilometers towards south. So your S2 in this diagram would look like this. So my second displacement S2 in component form would be written as minus 20 G cap. Correct. And again the unit is kilometers. Okay. Now the thing is S3 you cannot see in this diagram. Okay. So S3 is actually like a line coming out. So I'll just show it with a dot. Like you're seeing the tip of an arrow coming out. So S3 is a vector pointing out. Perpendicular to the plane of the diagram. And that one is 5 kilometers. So now again going back to our XY coordinate system, the direction coming out will be which one? It will be the positive Z axis. So use your right hand palm rule. So point your thumb along the X axis and point your 4 fingers along the Y axis. So you see your palm is like this. Palm is pointing outwards. So your palm is upwards towards you. So that means this direction is actually your direction of positive Z axis. Okay. So that is why my S3 as a vector should be written now as 5 K cap in kilometers. Okay. So make sure you understand this diagram here where I have drawn it in 2D. I have not drawn the 3-dimensional diagram, but now you can correlate it with the earlier diagram which I had made, which was kind of 3-dimensional. So this diagram is not very accurate. Your S2 will be only up to here, and then your S3 will be a very small displacement in comparison. Okay. But anyway, that's how the directions are looking. Now, once you've written the vectors in component form, you don't need to worry about anything else. Now you will just use your normal vector algebra to add them. S1 plus S2 plus S3. So it will become the sum of X components, which is 40 plus 0 plus 0. The sum of Y components, which is 30 minus 20 plus 0. And the Z components, which is 0 plus 0 plus 5. Okay? So that will become your net displacement. So once you've written the vectors out in component form, your net displacement or the resultant sum is very easy. It is just the normal addition type of algebra, which you've done up to 3 dimensions, done up to 2 dimensions a lot. And now you just extend that to 3D. So the sum of the X components you can see is 40. The sum of the Y components is 30 minus 20. So that is 10. And the Z component is only 5. So this is the net displacement in vector form or in component form. So its magnitude will just become that strange kind of number. So 1600 plus 100 plus 25. So it is, you can take 10 common outside and we'll have 17.25, which I'll give an approximate value, but it's okay to just leave the answer this. So this is fine. So this will come out to be nearly 41.5 times. But as I said, for our purpose, we can leave it in square root form. It's not a problem. Later, I'll teach you some nice approximation methods using something called binomial approximation method. How to calculate square roots like this quite accurately, okay, without using a calculator. But currently, you don't worry about that. It just right now, just concentrate on the vector part of the question. So this is like a real life application of 3 dimensions. Now, what kind of situation we'll use I cap, j cap, k cap? Okay, so this is the kind of situation. So I'm just leaving you with this for a moment. Yeah. Then we'll come back to some more questions. Just the whiteboard. I think some kind of a lag. No, it's fine. Okay, so now let's come to the slightly more tricky type of questions, which are based on those inequalities we were discussing about. Okay. So let's take a quick relook at the inequalities. So first of all, you have the general theorem that mod of A plus B is in between mod A plus mod B and the difference of mod A and mod B. If we write it very formally, we'll write it like this. We've been used to taking mod A and mod B just as A and B. But okay, so whereas, so this case occurs when theta is equal to 0. This case occurs when theta is equal to 1. And for all other cases, it is in between these two. Similarly, mod A minus B also has that same range of values. Its maximum possible value is the sum of the mods. But the difference is that for A minus B, the value is equal to this when theta is equal to 180. When they are anti-parallel, then the difference actually results in the sum of the magnitudes. And when they are parallel, the difference actually results in the difference of the magnitudes. So this is, the most general so-called triangle inequality theorem. These are called the triangle inequalities. But we also had some additional ones, and the additional ones were like this, that also for theta being less than 90 degrees, or theta basically being between 0 and 90 degrees. Okay, so when we have an acute angle, you also know that mod of A plus B becomes greater than root of A square plus B square. Or in general, for this statement, we can say that mod of A plus B will be greater than equal to the difference of A minus B. Oh, sorry, greater than equal to greater than root of A square plus B square. But less than equal to E plus B. So for example, if we had mod A equal to 12 and mod B equal to 16 and theta is acute, then E plus B's maximum possible value it will become how much? It will become 12 plus 16 or 28. But at the same time, a plus b is minimum value. This thing is minimum. Will actually be greater than 20 because theta is acute, so it can't be 90 also. Theta is less than 90. So that means the minimum value is something slightly greater than 20. So that means here mod a plus b is something in between 20 and 20. So it cannot be something like 19.5 or it cannot even be 20. It has to be greater than 20 but at the same time less than equal to 20. So that is the condition of acute. But similarly, if theta is obtuse or theta is greater than 90 and less than equal to 180. So now what happens? Your mod a plus b is actually less than root of a square plus b square. At the same time is greater than equal to the difference of a minus b. So that same question, if a is 12 and b is 16 and theta is greater than 90 degrees, then over here what we can say is that the maximum possible value of a plus b is something less than 20. It cannot even be 20 because this is not 90, it's greater than 90. But at the same time, it cannot go as low as anything below 4. The difference is 4. So the minimum possible value of a plus b, a plus b is magnitude is 4. The maximum value is actually slightly less than 20. It cannot go exactly to 20 also. Okay, so this is what we have to understand in terms of inequalities. Okay, so let's do a question or two based on this. So now suppose we have a system that is given like this. The vector A is like this. It has a magnitude of 10 root 3. And vector B is something like this. We don't know the angle, but we know the magnitude of vector B is 10. Now, which of these are correct? So magnitude of E plus B is greater than 20. I'm just making this question a little lengthier. So this is not your exam pattern question because you have only 4 options. In the last 2, you will have to think very carefully. Okay, so you have to select all the correct options out of this. This is not an exam level question because there are, as you can see, 8 options. You get only 4 option questions. But this is just for your own practice. Okay, so let's understand that given this diagram, okay, which of these options we can definitely say are correct and which of these options we can definitely say are wrong. This will clear out our concepts of all inequality based questions. Yeah, I'm beginning to get the answers. Dhruv, unfortunately, your answer is not correct. Chinmay, let me just check. B is correct, of course, for you. So, yeah, Chinmay, I think your answers are correct. Yes, Chinmay, good. Your answers. Just a moment. Chinmay, you have to be careful about the last two. Okay, between the option G and H, you have to be careful. The other options you have selected are correct. Okay, people, let me give you the answers first. Okay, and then we will come to what kind of logic you have to allow. Okay, so I'll just go each option one at a time. Okay, so you can see over here that रूट ऑफ ए स्क्वायर प्लस बी स्क्वायर का वैल्यू कितना है पहले वो कैलकुलेट कर लो 20 है, ठीक है। फिर सम ऑफ मैग्नीट्यूड्स का वैल्यू कितना है, इट इज 10 into root 3 plus 1, that is not come anywhere, and difference of magnitudes का value कितना है, it is 10 into root 3 minus 1. Let's keep that in mind first, okay. And let's also understand from the diagram that my theta is obtuse. So theta is obtuse means that cos theta must be a negative quantity. So once we have all this data in place, now we are in a position to judge which is correct, which is wrong, okay. Because we have to just think of the formula. So when we are talking about a plus b, we know the magnitude of a plus b is given by what formula? It is given by square root of a square plus b square plus 2ab cos theta. Okay. So I can see that this quantity here is 400 and this quantity is negative. So obviously this is the correct option and this is the wrong option. Okay. And definitely it cannot be 20. It has to be less than 20 because you can see it's not 90 degrees. And yes, obviously it has to be greater than, because this is a universal fact, because it is always greater than difference of a and b. Okay. Now at the same time, let's also think of mod a minus b and let's relate that. The next set of options is about that. So mod a minus b is square root of a square plus b square minus 2ab cos theta. Now keep in mind that this quantity is 400 and this cos theta is now negative. So obviously this is becoming greater than 400. So which option is the correct one? This is the correct one, this is the correct one. Okay. And now you can see logically here only that mod of a plus b is less than 20, this is greater than 20. So that means this option is wrong and this is the correct one. So the options which are correct are B, C, E and H. Yeah, I mean, this was like a monster question. So don't worry if you forgot some option or something. This is just so that in one question itself we are understanding how to apply all the logic of the triangle inequalities. Yeah, we'll do more questions also. Why f is wrong, beta? Because see, you can see in this thing over here that mod of a minus b is root of 400 minus 2ab cos theta, but cos theta is negative. So that means it is it's basically equal to root of 400 plus something, because that minus minus will become. So it's obviously greater than root 400 or greater than 20. Yeah, so that's why we are doing these questions now. Okay, so now next example. If the angle theta between two vectors A and B is such that theta is greater than 0 but less than 90. Then which of the following is, now again this is going to be a tricky question. So option A here saying that mod of A plus B is greater than mod of A minus B. Option B is saying that mod of A plus B is less than mod of A minus B. Option C is saying mod of A plus B is okay. So let us work out all these options. Yes, Manas, I think the options you have said are correct. I have to check all of them, but the ones you have mentioned are correct. Ask me, it's correct. Ask me, your options are all correct. The ones you have said are all true. Arnav, correct. Harpriya, correct. Yashovardhan, no, one option is wrong in yours. Pritesh, you missed out some options. Okay, so see, this kind of question can get a little confusing initially. So till you get used to doing these inequalities, you just work it out like this, that just start with the language of the question about theta. So given that theta is greater than but not equal to 0 and less than but not equal to 90 degrees. So what we can say about cos theta? Cos theta cannot be equal to 0 because it's not equal to 90. So it's always greater than 0 and it's less than 1, cannot be equal to 1. Okay, because you know that cos 0 is 1 and cos 90 is 0. Okay. So this is what we can say about cos theta. So basically cos theta is a fractional quantity which is less than 1 but greater than 0. Like this. Okay. So now what we can say about mod of A plus B, that is equal to root of A square plus B square plus 2AB cos theta, where we can see that cos theta is basically a positive fraction. It's not zero. It can't be zero. It can't be unity. It's a positive fraction. It's between 1 and 0. So therefore, what we can say about a plus b is magnitude. A plus b is magnitude is definitely greater than root of a square plus b square. Because this quantity over here is definitely positive. It can't be zero also. So the quantity inside the square root is definitely greater than a square plus b square. But at the same time, this is not going up to unity. That means the quantity inside the square root is not going up to a plus b ka whole square. It is less than a plus b ka whole square. So this is less than. Because this thing shows you that the right hand side cannot go up to a plus b whole square. So this is one thing. This is one statement. And similarly now we can also tell using this same thing here, the same relationship of cos theta here, and also tell something about a minus b as a vector. Magnitude of a minus b is root of a square plus b square minus 2ab cos theta. But again we understand that people, yeah, I'm just having some internet issues here. So I have reconnected by my 4G. So I'll have to restart my modem. It will take me a little bit of time. So just continue with this question in the meantime and take a 2-minute break because I'll have to see why my internet suddenly switched off. Okay. So just give me a minute to sort it out. So take a 2 to 5 minute break. I will sort out the internet problems. Okay. Hopefully you people are able to hear what I'm saying over here. I will also just send you a message to confirm the same. Okay, students, just hang on a second. Sorry about that. Right, students. So almost online again. Just give me a moment to launch the whiteboard. Right. So back to the question we were discussing. Here it comes. I'm talking again. Right. So let's take a recap of the whole question. So the original question was that this was the condition given to us, that we have two vectors such that the angle between them is greater than 0 but less than 90. And then we have to mark out all these options which have to do with the relationship between mod of a plus b with respect to mod of a minus b, and the individual relationship of a plus b with root of a square plus b square, and the difference and the sum and all these things. So for that, what we did first was to analyze that, okay, if theta is in this range, greater than 0 but less than 90, then what we can say about cos theta? And the answer to that is this is what we can say about cos theta. So this is what we can say about cos theta. Then based on that, what can we say about mod of a plus b? So when you're looking at mod of a plus b, it is root of a square plus b square plus some quantity, where this cos theta is a positive fraction. So the quantity inside the square root, it cannot go up to a plus b whole square. It's going to be less than a plus b whole square. And at the same time, it cannot be root of a square plus b square. It has to be greater than root of a square plus b square. So that is what we can say about mod a plus b. Now similarly, when we analyze the magnitude of the difference, you can see that it is this. Now cos theta in this is a positive fraction. So this thing cannot be a minus b whole square. So it's always going to be greater than a minus b whole square. So that means mod of a minus b is greater than the difference of their magnitudes. But at the same time, it's never going to become root of a square plus b square also, because it's not going to go up to 0. It's going to be a fraction which is positive. So this quantity will always be a square plus b square minus of something. This something cannot be 0. So that means this is root of a square plus b square less than that. Okay. So this is what we can say about this. Now, if we pull together these two statements with what we have seen in the options above, we'll be clearly able to analyze which options are correct and which options are wrong. Okay. So you can see that finally from that, what all we are getting is that E minus B, or let's start with E plus B. E plus B's magnitude has to be greater than root of E square plus B square. E minus B's magnitude under all circumstances has to be less than root of A square plus B square. And A plus B's magnitude has to be less than, the upper limit is the sum of the magnitudes. And similarly, A minus B's lower limit is the difference of the magnitudes. This is what it is. So put together all this with this, you can see that if you just connect this statement here with this statement here. This is always greater than this, is always less than this. That means this has to be greater. That means this option is wrong. Okay. Then you can see obviously this is telling us that this option is wrong, but this option is correct. Then this is saying that mod of A minus B may be equal to A minus B, but for that to happen, the angle has to be what? 180. The angle has to be 0. When is the difference of A minus B vector equal to the difference of the magnitude? For this, the condition is theta has to be 0. But here theta is not 0, na? Theta is always greater than 0. So that's why we have this condition, that this always has to be greater than mod A minus B. It cannot be equal to. So that means this option is becoming wrong. It cannot be equal to this. And similarly, mod of A plus B. Okay, so for mod of A plus B to be equal to A plus B, the angle has to be how much? The angle has to be exactly 0. But again, here it is greater than 0. So always it is less than this. So that's why this option. So our final answer therefore is becoming A, D, F, and G. These are our final answers. Okay. So this kind of question can become a little bit tricky. Okay, which is why, I mean, you will not get something so tricky in one question because so many options will not be there. If you just check 2 or 3 options, because 1 or 2 you can always rule out, 4 options and all, 1 or 2 so logically you will rule out. So you just have to look carefully at 2 of the 4 options or 3 of the 4 options. But I'm just giving you this like a Godzilla type of question, so you can manage anything big. Therefore, anything smaller than that will become an easier monster to handle, something like that. So I'll just leave you with the analysis of this for another moment, and then we'll see another type of question where you can see this kind of theorem working out straight. Okay. So what was the logic behind all this? The logic behind this was this. Given the range of this was given, so we got from this, we got this thing. We got this and we got this. We got this. Now once you got these two, we can check all the options. It's just a matter of logically being just careful and being patient about which options are correct and which options are wrong. Everything you want to analyze about the question now lies in statement 1 and statement 2. And where have statement 1 and 2 come from? They have come from that analysis that cos theta is a positive fraction. It's definitely greater than 0, but it's less than 1. Okay, people. So hope this is all clear. Just checking for your messages. Yes, it's a killer visualization problem, no doubt about that. Okay. Now, since you have asked about visualization, okay, let me also show you how we can geometrically visualize this. Now, that also becomes a very interesting thing. Okay. How we can logically analyze this is like this. How we can geometrically analyze this is like this. That let's take a case where theta is obtuse. Let's take a case where theta is 90 degrees, and let's take a case where theta is acute. And remember how I told you to visualize A plus B and A minus B in the same thing. That is what we have parallelogram law for. So if A and B are such vectors which are obtuse, you can see that their vector parallelogram will look like this. Yes, because the angle is obtuse. So when you analyze for this parallelogram, now when you analyze the sum and difference vectors, you can see that the sum, which is the primary diagonal, now in the diagram you can see that because this angle is obtuse, this is actually the shorter of the two diagonals. So the primary diagonal is actually shorter in length. You can just understand that visually. And the secondary diagonal is actually longer in length. So that means whenever theta is obtuse, what is happening? So this is showing you that theta is obtuse. Immediately it shows you visually that what is happening, mod of A plus B is less than mod of A minus B. What you well know by using the triangular formula and all that. But now quickly you can visualize that theta obtuse है मतलब ऐसा stretched है. So that means this diagonal is getting stretched to a longer length. this diagonal is getting compressed to a shorter length. So it's like this. Whereas whenever your theta is exactly 90 degrees, you can see that it's a rectangle. It's reduced to a rectangle. It's a very obvious thing that the two diagonals are equal in length. So in this case, your mod A plus B will become equal to your mod A minus B when theta is 90 degrees. So these two statements imply each other. Whenever we know we have perpendicular vectors, we know this property is true, that mod A plus B is equal to mod A minus B. Or on the other hand, if we say we have two vectors whose sum and difference are same magnitude, we know that that means the vectors must be perpendicular, because this is the only geometrical situation which is possible. That this diagonal is equal to that other diagonal, which is in fact numerically equal to how much? It will be root of A square plus B square. This will in fact be equal to root of A square plus B square. And the third case is the case where the angle is acute. So that time you can see that the parallelogram that you draw will be naturally in this kind of a shape, where the primary diagonal will be the longer of the two diagonals and the secondary diagonal will be the shorter. So just by visualizing the parallelogram, it's very obvious to you that here it is the sum which will be larger and the difference which will be lesser in magnitude. But theta is acute. It is the primary diagonal which is longer. So magnitude of A plus B is longer than magnitude of A minus B. So you can also just remember that these secondary inequality theorems, the ones which are to do with angle being acute and obtuse, by just remembering these three diagrams. This is where the parallelogram law becomes very useful in visualization of sum and difference at the same time. Otherwise, in terms of calculation, you don't really need anything else. You already have the triangle law, that is more than enough. Or as you will see in many questions, the easier way to do calculation is by making it a component-based question. Just write everything in I cap, J cap notation for 2D or I, J, K for 3D and just proceed with the component method. But it's when you want to do these kind of comparisons, when you want to check the inequalities and all that, that is where this parallelogram law becomes a very useful tool to compare the sum and difference of two vectors at the same point of time. Okay. So don't worry about difficulty level of questions coming in the test and all that. I've already told you the maximum difficulty level is going to be your worksheet 4. Okay. Today's class exercise is just to give you some additional practice. Some of these questions I've done with where there are 8 options and all that, they are extra tricky questions. They are not the level of sums which are going to come in your test. The sums in the test will be a smaller subset of that. It's just to give you the full picture logically of how to analyze a question with inequalities. Okay. So we will conclude with one final question where you will see that we're going to make use of these things. Okay. So my final example for today, I believe it's question 10 or 9 or one of those. So again, it's a diagram based question. Now in this question, the vector A is given like this. This angle is 30 degrees and let us say its magnitude is And the vector B is actually shown like this. And its magnitude is 20. And this angle is 30 degrees. And these are our standard XY plane. So the first part, express vectors A and B in component form. Second part, find the resultant of A and B in I cap, J cap or component notation. Third part, find the magnitude of A plus B. And fourth part, compare the magnitude of the sum with the magnitude of the difference. So you have to just tell which one will be larger, which one will be shorter, etc. So just try this question out. Right, so hope you have started working this out. Yeah, I'm getting some messages already. Correct, Manas? No. The vector B has a negative x component and a positive y component. This is where you have to understand, beta, all of you, that in this, the direction of the vector B, though I've drawn it in the fourth quadrant, but where is the origin of the vector B? It's here. No? So you have to understand its direction is like this actually. The direction of the vector B pointed in this sort of direction. So it's actually in the second quadrant. Okay. So that is why to draw the vectors, I mean to write the components properly, you are better advised to actually redraw them both from the origin so that you understand the angles very carefully. So vector E was no problem. Vector E was drawn from the origin itself, so I don't need to make any change. So its magnitude was, what was it, 15, and this angle was 30. the vector A in component form will become 15 cos 30, so that is 15 root 3 by 2 I cap plus 15 root into half G. So this is your vector A. Vector B is the one where you have to be a little bit careful because the vector is drawn pointing at the origin. So you have to redraw it to understand that it's actually lying like this. So vector B is like this, where its magnitude is 20, but also was along this line, where this angle was 30. So over here, this angle is 30. So the angle that vector B is making with the x-axis, that one is how much? It is 120. So B's x component will become 20 cos 120, which is minus 10, and B's y component will become 20 sin 120, which is positive of 10 root. So the vector B in proper component form is minus 10 I cap plus 10 root 3. This is the problem. So now coming to the rest of the question, the resultant of A plus B in component form, that will become 15 root 3 by 2 minus 10 I cap plus 15 by 2 plus 10 root 3. Okay. So now if you want to calculate the magnitude, you have two options. One is you can use the component which is directly given. So you have to calculate mod of this vector. But that, as you can see, is going to be a very lengthy calculation. It's avoidable. But I'll just do it for you anyhow to demonstrate that that also works. So इसका mod क्या हो जाएगा? It is square root of this whole thing squared plus this whole thing squared. So if you patiently work this out, it actually comes out to be a whole number. Interestingly. So 225 into 3, so that is 675 by 4 plus 100, okay, minus 150 root 3. That is the first part. Then we have 225 by 4 plus 100 into 3, so that's 300. Okay, and this becomes plus 150. So this term and this term interestingly cancel off, and what we are left with finally will be square root of 675 plus 225, so that is 900 by 4 plus 400, so that will become square root of 2500 by 4, so that is 50 by 2 or 25. But in a moment I will show you that all this was completely unnecessary. We have put too much effort over here. We should have just observed something from the diagram which is very, very obvious, and which would have made 25 very obvious as the answer. But anyhow, if you have gone with this, you can see this. Okay, this is it. Now why this is all unnecessary is because if you look carefully in the diagram, you will realize that the angle between A and B, that is how much? That is 90. If you look at geometrically, theta is equal to 90 degrees is the angle between A and B. So that immediately actually helps you with this, and not only that, it also helps you with the fourth part. Mod of A plus B will actually be equal to mod of A minus B. which will be equal to root of a square plus b square, or 25, because A and B are perpendicular vectors. So this is just to show you that there is no hard and fast rule that this question has to be done by components, that question has to be done by geometry. And just because one part we have done by components, the other part also we have to do by components only. We have to be very alert and keep our eyes open for anything that might help us solve the question faster. So the moment you saw that this angle is 30 and this angle is 30 here, it should have struck you that okay, they are perpendicular vectors. So when you were comparing mod A plus B and mod A minus B, that theorem must have struck you that okay, angle कैसा होना चाहिए, obtuse होगा तो mod A minus B is larger, acute होगा तो mod A plus B is larger. But in this case it's 90, so they are equal. And not only that, in that case the magnitude just becomes root of A square plus B square. Okay. So you would have avoided the calculation heavy part, which is this one. Obviously, the first and second part is about components. You've been asked to find an I cap, J cap, so you have to do. But the third and fourth part, just the simple observation from the diagram that they are perpendicular vectors will save you a lot of time and energy. Okay, so that is the thing. People, that is more or less all check. So I will give you the PDFs by tonight only for the questions that you've done in class. So revise them once more, and you will see that that will help you a lot for your preparation for the upcoming test. If the questions in today's class are clear and you have worked out everything up to worksheet 4, any pending notes and all, just try to clear by tomorrow, day after with me, if anything is remaining. But I think for most of you it should be clear. Okay. So in that case, you are well prepared. You don't really need to worry about anything to do with vectors. And in general about the test, I'll tell you so much that there will be a 3-hour test with equal number of, with 3 sections, physics, chemistry, and maths. So each section will have 25 questions, 25 for physics, 25 for chemistry, 25 for maths. And in that, in physics, 12 of the questions will be vectors and 13 of the questions will be kinematics, or vice versa. I won't reveal that just now, but more or less equal number of questions for each of the topics. Okay? And that's it for today's lecture. All the best for the test coming up. Any last moment doubts and things, make sure you contact me and